lot more than we use set notation. But just so we have it, I showed it to you. That's about all we need to do with that. So what we're really going to talk about today is some polynomials. So this is the technical definition of a polynomial. It's a collection of variables and constants on which operations are performed. That is an algebraic expression, and we typically use them as some form of a polynomial. Monomials mean it's a one thing. So monomials typically look like this. A constant, a variable. The variable may have a power, it may not, but it's just a constant and one variable, nothing added, nothing subtracted, nothing extra. One term, 2x, 3x squared, 1/3 x to the 4th, 27y. All of those are monomials. Binomials, think like bicycle. It is an algebraic expression, so things being added and subtracted together, made of two bicycle, binomial, two monomials. So let's switch this so you can actually see stuff. So we've got an algebraic expression good, the pink shows up on the blue. Of two and only two monomials. Constants also count as monomials. It could be x to the 0. We could have 3x to the 0, which would just be 3. So a binomial could be something like x plus 2. X squared minus 7x. 37y to the 17th plus 2y. Like any number of things, if there's only two things, it's a binomial. Similarly, trinomial, tricycle, 3 wheels, 3 terms. So trinomial, it's the same exact definition, just swap the 2 for a 3. And oh my gosh, will you let me zoom out? Thank you. So a trinomial is an algebraic expression of 3 monomials. So all polynomials are built out of monomials. Monomials are the building bricks of polynomials. We tend to refer to them all as polynomials. Monomial, binomial, and trinomial are just more specific. So polynomial just means it's built of any number of monomials. It could be smaller, or like it could be higher. It could be 5 terms. It could be 20 terms. It could be 2. A binomial is still a polynomial. It's very similar to the all thumbs are fingers, but not all fingers are thumbs kind of deal. This is the more specific name, and this is the general name. So a polynomial is an algebraic expression. We'll notice it's very similar. Made of any number of monomials. Close to the edge of my hand. There we go. Got it. And we don't have to write the word monomial any more times. I know that one's a lot. Got a lot of M's and a lot of N's. Oh, I'm sorry. There's one more time we have to write the word monomial. My iPad was sitting directly on it. Because we're going to talk about degree a little. We use it a little bit. And the degree of a polynomial is the highest exponent you have. Any individual term. So the degree of a polynomial, I'm going to change colors. We're going to go back to pink. Just go to, actually, no, I'm going to get a dark blue. Boop. There we go. Our degree is the highest exponent of any monomial. And this is the last time we write it. Any monomial in the polynomial. So if we look at something like x squared plus 2, the highest exponent in that polynomial is a 2. So its degree would be 2. It was x cubed plus x squared minus 7x. Our degree would be 3 because 3 is our biggest exponent. It is the biggest exponent of any term. Our leading coefficient, which we will use in things, our leading coefficient is the number which, if we're using this expression here, it would be a. That's in front of the highest degree term. And I know there's like no space between those letters, I'm sorry. I'm gonna hold and see if we, okay. So if we had a polynomial, I'm just gonna write one down here, you don't need to write it down. Like if it was 3x squared minus 7x cubed plus 12x plus, I don't know, 27x to the 5th. What would our degree be? 5. What is our leading coefficient? 27. Okay. It is the number with the biggest degree. That's what we're working with that. We are gonna today work with polynomials. And then I believe tomorrow we also work with polynomials because we got to remember how to do factoring. Everybody's favorite. But we're not going to start with factoring today. We're going to remember how to add and subtract some polynomials together. I will zoom them in because I know these have a gazillion pieces. So we're going to add and subtract some polynomial expressions. Boop. So here's our first one. When we are adding and subtracting polynomials, we usually call it something else. I don't remember what we could, like, what would we do here? Combining like terms. It's 100% the same thing. When I have stuff in parentheses like this and it's an addition in between, are my parentheses actually doing anything?
Yes.
Are they?
Not really.
Not really. Because when I add stuff, it doesn't matter. I was gonna say, if it's subtraction, that does do a thing. But if we're adding, not really. They're kind of just in the way. So we're just combining like terms here. So I tend to do things color-coded. So I'm going to take my x cubed and my 4x cubed and add those together. What do we get? 5x cubed. Doesn't change my exponent when we add. I have One thing plus 4 things. 5 things. How many x squareds are we going to wind up with? -3. I have 2x squared minus 5x squared, and we get minus 3x squared. Did I hear a weight? Okay. How many x's do we wind up with? -5. I don't have anything to combine with it, so he just gets to come on down to the party. And what's our constant? 10. See, we remember how to do this. Not anything more to it. That's our answer. We did it. So adding and subtracting polynomial expressions is just combining like terms. Let's do another one. And I'm going to give you guys a second to write it down because I know these have a gazillion pieces. All right, so now I'm going to ask again, are my parentheses doing anything here?
Yes.
Yes. What do I need to do before I can combine like terms? Distribute the negative. Which way? To the left or to the right? To the right. Please, only go to the right, thank you. Just saying, I usually have somebody on the first homework that winds up doing it the wrong way. So we're going to take this minus sign and distribute it to all those pieces. I'm going to rewrite the whole thing. If you don't need to, you don't have to, but that's too many steps to do in my head for you guys as a show. 4x cubed plus 5x minus 3. I can drop my parentheses because now they're not going to do anything that I distribute that minus sign. We're going to subtract our 3x cubed. We're going to subtract our 2x squared. We're going to subtract our 4x. And then we add the 3 because we distribute that minus sign to the minus sign. And now we're going to combine our like terms. What do we get when we start combining like terms? 1x cubed, which you don't have to put the 1, but I'm going to put it for right now. Minus 2x squared. Plus 1x. Again, you don't have to write the 1. I tend to write it just so that we're clear. And then what? And that's it, because minus 3 and plus 3, and they cancel out. Why did we decide to put the x squared in front of the x, even though there wasn't one over here? I was like, you guys all made that choice. I want to know why did we make that choice? Yeah. Typically, when we write polynomials, we put them in a standard form, which is from biggest to smallest exponents. That is best math grammar. For the most part, it's okay if we kind of switch them around because, again, it doesn't matter what order we add or subtract things in. But it's, especially when we start getting into factoring and things like that, having it be in that standard form, the biggest to smallest exponent order, is going to make your lives easier. So, I'm not petty about it, but it does make your lives easier when we get into harder things. And you guys all did that, like, on instinct. So, I was just pointing out what we did on purpose. Questions about either of these two? Okie dokie. Boop. We gonna remember how to multiply them now. There are several options on how to multiply them. You may box them. Some people may remember FOIL. We may do distribution. I'm typically going to do them as a distribution simply because it takes up less space. If you want to do the box tool, you absolutely can. It's an area model is what that's called. It is probably the slowest, so it might be something that we work towards moving out of using the box model, but it's absolutely valid. And if you don't know what I mean by the box model, that's when you take and you write the literal box and you put things on the outside, this thing, 3x minus 2 and 4x plus 5. You can absolutely do it this way. It's fine. It just takes the longest. So I'm going to actually erase that because I'm going to do this as a distribution. Because we need to multiply everything on the left by everything on the right, which means I'm going to take my 4x times my 3x, and what do we get from that? What is 4x times 3x? 12x squared. We're going to take our 4x times our minus 2. What do we get? Minus 8x. 5 times 3x, 15x, positive 15x. And 5 times minus 2, negative 10. Any questions on where I got any of those pieces? Because I got one more step here. What can I do now? Combine some like terms. What are my like terms? The minus 8x and the 15x. What do we get when we combine those together? 7x. Positive 7x minus 10. So, familiar, but it's been a minute since we did it. It's been a minute. And that's why we're going through this. I know this is all stuff you guys know, but it's been a minute and we need it all refreshed because eventually we're going to do some funky things with these. All right, so the next one, I actually saw some people make some mistakes on a problem like this that was on the last homework. It was involving the exponents over a quantity. Can I just put this as minus 3x squared minus 7 squared? Not the same thing. This is that quantity, our minus 3x minus 7 times itself. So we need to take our minus 3x minus 7 times itself. And we're going to distribute again. I cannot take a power and do a distribution with a power. If it is a polynomial in your parentheses, you have to multiply it out. We cannot distribute it. It is not power over power when there's addition or subtraction inside your parentheses. So, we're going to multiply this out again, same way. Minus 3x times minus 3x. What do we get? Positive 9x squared. Minus 3x times minus 7. 21x, positive 21x. Boop. And then we're going to have our minus 7 times minus 3x. We get another 21x. And then we have our minus 7 times minus 7. Positive 49. So make sure we're being careful when we have polynomials with exponents outside like this, that we don't try and shortcut and do like a distribution with a square. Because then I know you guys know, but we gotta like know. Because our for realsies answer is not just gonna be 9x squared plus 49, which is what a lot of people would show on that. We're gonna have our 9x squared plus 42x plus 49. What is the next thing I have on there? I don't know what that says. Oh, okay, cool. All right, questions on these? Oh, helps if I zoom it out so you can actually see all the things. There we go. Questions on these? Because we're going to do one more multiplying challenge mode. Because it's not going to be a binomial times a binomial, or even a binomial squared. Trinomials. Zoom it in so you can see it. We are going to approach this exactly the same way. It's just going to be a beast and crazy long. Because I have 3 terms times 3 terms, which means without simplification, we're going to have a lot. So I'm just going to read it out so you guys can write it down. So we've got our 2x squared plus 3x minus 5. That's our first polynomial. Second polynomial is x squared minus x plus 4. Follow the same path. We're going to do some distribution. I tend to do it as my first term times the second polynomial, then the second term times the second polynomial, and then the third term times the third polynomial. You can do it in whatever order you want. It doesn't matter what order we do the multiplication in, as long as we make sure we're keeping track. That is why I tend to do things with all colors. You'll see me use colors a gazillion times. So you guys, if you're not watching me draw it, can kind of figure out where I got the piece from. So we're just gonna start plowing through. So I'm gonna take my 2x squared times my x squared. It's gonna give me 2x to the 4th. I'm gonna take my 2x squared times my minus x to get minus 2x to the 3rd. And my 2x squared plus 4, times my positive 4 gives me 8x squared. So now I've taken that whole first term times my whole second polynomial. Then we get to do that again with my 3x. We are not going to have tons of these that are trinomial multiplication, but like. So I'm going to have my 3x times my x squared. It's going to give me my 3x cubed. Then we're going to have our minus 3x squared and our plus 12x. One more set, and I'm going to take this on the bottom because it's getting very stripy up there. So we've got our minus 5 times x squared, so we have minus 5x squared. Positive 5x minus 20. And I know a lot of you guys are working ahead of me, and that's okay. Simplify it, and what do we get? Combine our like terms here. 2x to the 4th. 1x cubed. 17x minus 20. My x squared's canceled out. You can write the 0x squared if it works for your brain. If that helps your brain, write it. Totally fine. But not something you have to write. On the water. Questions on this one? This one is probably our most annoying one of the day. Just to say. We are going to do 2 more problems. But they are not multiplying. So I feel like we got the hang of it. This is something we've done a gazillion times. We are going to remember how to divide by a monomial. Dividing a polynomial by a monomial. So I'm going to bring it in on this left one so we can see it, because I know especially when it's fractions, they get real small, especially in the exponent. So dividing by a monomial. This is for when we have no addition or subtraction in our denominator. Does anyone remember how to do this? Say it's been a minute. That's not something we do super frequently. The easiest way to do this is to uncommon our denominator. So instead of having this be one giant fraction, I'm going to break it apart so that we have 8x to the 5th over 2x. And then we're going to subtract 2x cubed over 2x. And then we're going to add 6x squared over 2x. So we're going to break it apart into separate pieces. So it's like the opposite of trying to make it have the one common denominator. Because then I can just look at each of these little fractions individually and simplify them. Looking at just this piece, 8x to the 5th over 2x. What is that going to simplify down to? 4x to the 4th. 4x to the 4th. Then I'm going to bring down my minus sign, and we are going to simplify this piece. What's that going to simplify down to? Just x squared. And how about this piece? 3x. Ta-da! Okay? Not too bad. Break them apart. Simplify each fraction. The process doesn't change if there's more than one variable. So looking at the one on the right, same vibe. We're going to take the big fraction, break it into smaller fractions, and simplify each one in isolation, individually. And this is the last one for today. So I'm going to zoom it in so we can see. If you ever need me to put one of these back up so you can finish writing something down, I can always put it back up. I'm going to continue to drink from that empty cup until I remember to go refill it. So we're going to break it apart into our separate pieces here. We've got our 3m cubed n to the 4th over m cubed n squared. And then we're going to have our 2m to the 5th n squared over, that's not how I draw an m cubed n squared. And on the last one, you can either write it a couple of times, or you can do this squaring as you split them apart. We've got our m squared, n squared as a quantity squared. So what is that going to be when we write it in our numerator? M to the 4th, n to the 4th. Since there's not addition in there, this is just power over power, and we don't have to distribute. We only have to do our distribution when there is a polynomial inside, not a monomial. Monomials is power over power, exponent rules. If this was m squared plus n squared, then we would need to do our distribution. So simplify each one of these fractions. What do we get when we simplify this one? 3n squared. How about this one? 2m squared. And our last piece here, mn squared. Okay? So again, things we've done, but it's been a minute, and it's been like a hot minute since we did it. Okay? So I'm going to put up the homework 1.3. Again, I've highlighted what we talked about today. Tomorrow we are currently scheduled for a quiz, and then we're going to go through factoring. So the rest of these questions are going to be factoring questions. You may remember how to do that. And if you do, go for it. Absolutely no problem with you working on stuff that's not in the highlighted questions. Totally fine. It's just we talked through up to 36. Everything else should be a factoring problem. Okay, and you guys have about 5 minutes till the end of the period. The answer key for homework 1-1, the one I just passed out, is up on Canvas. I only checked the ones that had little check marks next to them. So check your other answers. I did not look at I just saw that they were done. Because our points on homework is a mix of completion and correctness. I'm not going to grade every single question, ever. I don't have the time for that. But I will usually pick 1 or 2 questions to grade for correctness. Oh, that date is wrong. Today is this. Today is the 7th. Today is also the day that homework 1-2 is due, so please make sure you turn that in. I just don't have it up here on the slide. And since you guys are 3rd period and you guys probably all haven't had study hall today, if you have one, if you turn it in before the end of the day, that is fine with me. So if you guys ever want to finish up and just bring it back before the end of the school day, totally fine with me.